So a superclass called soccer player will have its properties and methods inherited to come up with some subclasses such as forward, midfielders, defense, goalkeeper. All of them have inherited something from the soccer player, which is a high hierarchy class. Now we have types of inheritance. So we have the following, depending on how they are implemented, or depending on where you're inheriting from and how many classes are involved in that inheritance. So the first one is a single inheritance, whereby in single inheritance, a subclass inherits the features of a single superclass. That means a class can acquire the property of another class, yeah? But that higher class is only one class. That is a single inheritance. But you can also have multiple inheritance. That is the second type of inheritance, whereby a class can have more than one superclass, or rather you can inherit from more than one superclass. Okay? So you inherit, a subclass will inherit from several parent classes. That is a multiple inheritance. Then you have multi-level inheritance. So in multi-level inheritance is a way a subclass can inherit from another subclass. Like you see, that is multi-levels, different levels. Yeah, subclass inheriting from another subclass. It's a multi-level. Then you have a hierarchy inheritance, a hierarchical inheritance. In hierarchical inheritance, a single class can serve as a superclass for more than one subclass. That is, just one superclass or base class can serve several other subclasses. So that is hierarchy. Then we have hybrid inheritance, which is basically a mixture of all the above types of inheritance. What is the importance of inheritance? So inheritance is good because we implement what we call an is a relationship and not a has a relationship. Okay, so is a relationship, of course we shall further define that, is a relationship that is normally inherited in implemented inheritance. Okay, not a has. The word is a and has a, they have a meaning which we are going to understand as we continue in this course. We are saying also we are reducing the element of having to write code every now and then. So you can reuse code which has already been made available in your base classes. So when you inherit, you're basically simply using that code that already has been made available. You don't have to create your own. Then we are saying you also apply methods which are in a class to different data types. So you may have different variables that are going to use one method. Yeah. So you see, that is making your code concise and simple. Because now if all my data types or all my variables can use a single method, then that means you've really reduced the level of or the size of your program. Another thing is inheritance helps developers to, kind of add some other levels. So you may inherit one level, which can be a shallow way, but you can also add some more levels. So it is a very nice way where programmers can modify some features. We also say if you have some global, or if you want to make some global changes to your program, you simply have to affect the base class. So if I change something in the parent class or the base class, it is carried down to all the derived classes that have inherited from that. The disadvantages can be there and advantages. Maybe let me just highlight a bit of the advantages. So one of the advantage of inheritance is we are trying to minimize the amount of duplicate code, because applications are sharing common code among the subclasses. So simply means that by reusing the code, you are basically reducing the element of having duplicate code in your program. And this is very important because it will result into a better way of handling your program and making it smaller and simpler to run faster. Inheritance also can make your application code more flexible to change, because classes that inherit from a common, for example, superclass, they can use the code interchangeably. Just as I said, you'll find like several subclasses using a method that is available in the superclass. So you see, you have an application that is more flexible. Yeah. And then reusability element is whereby we are saying these methods that we define in some of these base classes are used without having to rewrite them. So reusability of a code is very important. Yeah? You don't have to rewrite some of these functions once they are defined in the base class. Extensibility will mean you can extend the logic of a class depending on your programming idea or business logic. So you're not just limited to whatever you've inherited, but you can extend some more classes. Just the way we had a class of a super class of a soccer player, and we are getting all other players. So it's some form of extensibility. And you can add some more methods in the derived classes, which might not necessarily mean that they are in the base class. Data hiding also is another element that is achieved when you do inheritance, because whatever data has been made private in the base class, or the base class can decide to keep some data private. We talked of static variables, whereby a class will make some of its variables to be just available within that class, and they cannot be available in others. So that is a way of hiding data, so that it cannot be altered by the derived classes, or probably the objects cannot alter whatever is in the parent. Then another feature is called overriding. We shall define overriding. So overriding is a way you may have a method with a single parameter or with a simple logic in the base class, but in the derived class you can add some more parameters to that same method. So we call that one, or basically, let me just put it this way. With overriding, you may have to replace a method that was in the base class from the derived class. So if you had inherited a method of the base class, but you want it to have a specific meaning in the implementation of the derived class, then you override it. To override means, in this case, is to overwrite it or to replace it. So that is also very possible with inheritance. Disadvantages of inheritance is that, you see, these classes are being inherited, and once you inherit, there is that increased time and effort whereby your program will have to reference to the methods and to the code that you have inherited from another base class. So there is what we call the jumping through all those levels for the code to be accessed by the base class, by the subclasses. So this one can increase the time and effort it takes for your program to run because of the several layers of abstraction that are above it. That means if I am working on a code in a class that has inherited from 5 or 10 base classes, then you see my program will have to jump to all those 5 to 10 base classes. So it will increase the time and the effort. Another disadvantage is this base class and the superclass, or superclass and the subclass, or the base class and the derived class are tightly coupled together. That means they are tied. If you alter one, you alter the other. So that tightly coupling means that this base class and the subclass cannot operate independent of one another. It can be a disadvantage because when you change, something may affect others. Also with time, due to maintenance and adding new features, both base class may have to be altered when you're adding, for example, there is a function or there is a method that you're changing its signature. Then that means all the other classes may be affected, or a change may have to be made also in the base classes. So maintenance also may be an issue. Another problem is also, or disadvantage, is once you delete a method, for example, in the base class or superclass, then you'll have to refactor the same. You'll have to think of what other classes are using this method. So now you see you may delete a method in the superclass and the rest of the classes may not work. So you see now that degree of independence is reduced. So you may have other disadvantages, but those are some of the highlighted ones. How do we implement inheritance, therefore? So let us look at base and derived classes, because we are saying the base class is the class that is in the higher hierarchy, and derived class is a class that happens to fall in the lower cadre. So a class can be derived from more than one classes, or we are saying a derived class can derive or can inherit data and functions from multiple base classes. It's like saying a child can pick different attributes from different parents, or from the mother and the father, and probably even further on from the grandpas and whatever. So to define a derived class, we use a class derivation list to specify the base classes. We are saying if a derived class is inheriting from several base classes, then you may have to list the names of one or more of those base classes that it is inheriting from. Okay, so you use the keyword class, of course, then the name of the derived class, then full colon, then access specifier, that is when you're inheriting the class you're inheriting from, which is a base class, it has to be public so that you can access its members. So we use a public class specifier. Okay, of course we have other specifiers such as protected, private, public, but when you're inheriting from a class, then the access specifier has to be public because you're inheriting. And if you're inheriting from several base classes, then you have to have like a list. Yeah. An example has been given there of a base class called shape, and from the shape base class you are deriving several classes such as rectangle, and this is an example of a single inheritance where you are deriving a class called rectangle from a base class called shape. So rectangle, a class, let me begin with the class that is defined as shape. One of its data members is the height and the width. And then some of the methods it has, it is setting width and setting the height. So if I derive a class called rectangle from a base class called shape, I'm inheriting the height and the width. Therefore, I can calculate area of the rectangle because I already have width and height supplied by the base class. So you see, I'll only have to put a function called get area in my shape. So there's an example given there where you define the two classes, the base class and the derived class, and then inside the main where the processing begins in a C++ language, you create now your objects of the class rectangle, or you create a rectangle object and supply the arguments there. So this is an example of a single inheritance, and as you can see, we are using the access specifiers such as the word public, private. Those ones are used to simply mean, are my members private? Can they be accessed by the derived classes, or they are just available for just the base class only? So if you use the word private, you simply mean you've restricted access to your data members. They cannot be accessed outside that class. If you make them public, you're simply saying you can access my data members or my members outside the class. If I'm using the word protected as an access specifier, that means I'm saying you can inherit from me. So we use the word protected to model inheritance. So there are several examples there given on how you can implement several types of inheritance. So we have an example of a single inheritance. You have a code there, a C++ code. You understand with C++ you have to begin your code with a header file, and then you define your class. A class has been defined there called value, and then it has protected members, data members such as a value, integer, is of integer type. Then it has a function called set values, which is void, and it is receiving a parameter A. Then within the body we are saying value, assign A to value, and we shall talk about what we mean by that. Then we have a class called cube, which is a derived class inheriting from value. So basically it will inherit the members of the class value, and then it has its own method called cube, which returns, of course, it returns cube, that is value times 3. No, I mean value to the power of 3. So inside the main you define the object of the class cube, because cube is a derived class. So we have an object there called cube, and then we are using the method setting values to set 5, so that value of 5 can be set to the container, and we can use that 5 to calculate the return. So we'll get 125. Multiple inheritance is achieved when you have more than one class that is acting as a base class. So when you have multiple base classes, we are talking about multiple inheritance. So this makes the members of base classes accessible in the derived class, resulting in better integration and broader usability. Yeah, so if you're inheriting from several base classes, then you have a broader way of reusing these classes and having a better integration. An example will be a class called polygon. So a class called cPolygon has the members such as height, and then it has a member called width, then it has some methods called input values. So here we are going to assign values, of course, to height and width. Then we're having another class called cPrint. It is a class also which with its own members. So it has a method called printing, which is going to accept a parameter called output. Then we have this class called cPrint. It has, of course, the printing method, which is defined outside the class. That's why you're having that scope resolution. Okay, then we have another class called rectangle, cRectangle, which is inheriting from cPolygon. So that means it will get the height and the width. It is also inheriting from cPrint class. So that means it's going to inherit that method of printing, which is in the cPrint. And its own method will be to return width times height. So it's going to give us an area. And then we have another class called triangle, which is again inheriting from cPolygon and cPrint. So it's going to have the height and the width set, and it's going to calculate the area and print the area. So in the main, you will have several objects. You have an object triangle, an object of rectangle, an object of triangle, and you can create several objects, and you can access the different methods which are available because of inheritance. So this is an example of multiple inheritance, whereby you have a derived class that is deriving from multiple base classes. Like in this case here, you have cPolygon and the cPrint. These are base classes. Now we had talked about friendship of classes. We also have friendship of functions or methods. So the functions within a class can also have some form of friendship so that they can access some members. Okay, so if functions become friends, then we are saying you use the keyword friend to declare them as friends. Okay, and as we said, you can have inline functions which are inside a class, and you can have some functions which are outside the class, but they are prototype is within the class. So we should remember that. So that is why the friendship element will give us an access to some of these variables. So apart from friendship of functions, we also understand classes also can be friends, and we talked about it, whereby one class can be a friend to another class, and therefore it, by virtue of friendship, you can access some variables or some members which belong to a particular class. So we use the keyword friend to make classes friends, and therefore they can share whatever it is by virtue of friendship. We talked about pointer to members. Now, pointer to members in C++, we simply say there's a way pointers can point to variables and functions. Because we said you can create a variable called pointer, which is going to store an address of a really variable that is elsewhere in memory. So when we are saying pointer to members, we are saying we have a pointer variable that is pointing to a member who is in a particular class. So we have a pointer. Maybe you can create even an object or a pointer object that is going to point to the real object that is in a class. Okay, so there is the syntax shown there for creating pointers. So you can point to a class and you can point to members. I want you to understand two things here. You can create pointers that are pointing to the class, and you can create a pointer pointing to the class members. That is the functions and the variables, the data variables. Okay, so don't get confused. Now you can point to a class, you can point to the functions or to the data members that belong in a class. So we normally use the arrow symbol to show pointer to members of a class, or accessing members through a pointer, of course. So pointers also can point to data members of a class, just as I have said. So the syntax will be the data type of the class name, then resolution operator, then the pointer name. So you know how to define pointers, use the asterisk and then the pointer name. Okay, so you can also assign pointers to members of a class. So you have your pointer name and you assign it of course, you use the class name and the resolution operator for data member name. But you use the ampersand to show that you're assigning the address, because pointers store address. So that's why you have to use the ampersand to show that you're picking the address of a class connected to a data member. So when you're working with objects, we say objects are instances of a class. You use the dot operator. So if you create an object of a class, you can use the dot operator to access the member functions of a class using the pointer. Or you can use an operator with the arrow operator to show that you're pointing to a data member. Okay, so get that one right. You have the object name, dot, then the member you're pointing to. Or if you're using a pointer, then use the dot pointer to the member. Or you can use the arrow to point to a member. So there is an example there given. I won't belabor so much on that. Yeah, so some more concepts with inheritance is that in a class we can have some functions which we use to construct or destroy variables, objects. Of course, when a class is defined, there is no memory that has been assigned. But when you declare an object, you have assigned a memory to that variable of object type. So for you to construct and assign memory to objects, you need a function called constructor. So constructor is a function that helps you initialize your objects to some memory. And if it runs out of scope, then you need destructors to destroy the object, because you need to free up the memory. That's why constructors will assign memory to objects, and destructors will clean up or deallocate the memory from objects. So it's a concept also you need to understand when you're working with classes, objects, inheritance, and what have you. Derived classes do not inherit constructors or destructors. But basically when you create a class, and automatically there is always a constructor. When you create a class and you create objects, automatically there's a default constructor which picks the name of the class. Okay, I want you to understand that a constructor is a function in a class, and it takes the name of the class. It can have parameters or it cannot have parameters. We shall talk more about constructors when we shall be talking about copy constructors, parameterized constructors, and default constructors of a class. But constructors are simply functions which are used to assign memory or deallocate memory from objects. Okay, and they always take up the name of the class. If I declare a class called base, and then it has a method called base inside it, then that method base is a constructor. Then also it can have another method called base, but with a what you call a tilde. That tilde symbol shows you that that one is a destructor. Okay, you can have a derived class deriving from the public base, but you can't have inherited base constructor. No, the derived class will have its own constructor called derived, and it can have its own destructor also. Here in assigned that tilde with that name derived. So whenever you create an object of a class, automatically constructors are called to initialize the object. You see, object is a variable like any other variable. So if you don't initialize it, then it's going to be given some values by default, which you call them some garbage value. It will hold some content that which you don't know. That is why the constructors can specifically assign something to an object explicitly. Then we have some more terminologies. We had talked about conversions, when you are to convert one class to another. So you can convert a base class to a child class, and a child class to a base class. So